there is a shortcut to predict the formula of an ionic compound. We know that lithium loses one electron to form a lithium ion. We also know that the electron is not lost, but transferred to a fluorine atom to form a fluoride ion. We have learned about how ions are formed, and that an ionic bond is the electrostatic attraction between oppositely charged ions. We will now learn about how to name the ionic compounds, and to deduce their formula from the ionic charges. Let us take the example of lithium fluoride. Step 1. Write down the ions side by side along with their charges. Remember that the charges are written in superscript. Step 2. Now circle the charges and take the number of the charge on each ion, across to the other, so that they are in subscript. Step 3 means that there is one atom. Omit the number 1 for lithium and fluoride. Combine the symbols and simplify the ratio, just like how it's done here, so the resulting formula is LiF. Did you get that, too? Let's try to work on another example. Calcium oxide. Step 1. Write down the ions side by side along with their charges. Remember that the charges are written in superscript. Step 2. Now circle the charges and take the number of the charge on each ion, across to the other, so that they are in subscript. We should get the following formula: Ca2O2. But 2 to 2 can be reduced 1 to 1. Omit the number 1 for calcium and oxygen. Therefore, the formula is CaO. If we were to think about it, everything we've described makes perfect sense. We know that ionic compounds have an overall neutral charge, so all charges present must be balanced. Do you have a piece of paper and a pencil on hand? Let's grab those and work on this example together. Aluminium oxide. We can see that to balance these charges, the aluminium ions must form an ionic bond with 3 oxides, ions. This concept is stitched together when writing its formula, Al2O3. We will learn how to name and deduce the formula of ionic compounds made from polyatomic ions, for example, magnesium hydroxide. These ones are harder, because the hydroxide ions are polyatomic ions. Instead, you have to memorize their formula and charge. Hydroxide ions are OH-. Magnesium is in group 2, so we'll have a 2+ charge, and we just said that hydroxide has a 1- charge. So for each magnesium, we're going to need 2 hydroxide ions, giving us the formula MgOH2, and notice that we put a bracket around the entire hydroxide ion. This is so that the little 2 in the bottom right tells us that we want 2 entire hydroxide ions, not just 2 hydrogen.